My name is Talinda Mngomezulu. I'm the accounting, economics, and mathematics tutor. Today we're going to be looking simple at the trigonometry graphs, and we'll start looking with a sine graph. And we want to build just a simple as well as a very fantastic and very interesting background or foundation how to plot or how to draw and how to analyze a sine trigonometric graph. We'll be doing this for all the trigonometric ratios, but today we'll be starting with the sine one. So now we know that the sine ratio is telling us that in the Cartesian plane, it is just y over r. And we have been given a Cartesian plane with a well-drawn of angles here, and we can see the angles, right? And we have been given a cycle with the radius equals to 1. That means all the points, so from the center to the circumference, will be equals to 1, because we know that radius are equal. And let us just move here. So what do we want to test now? Let us test all the angles that are being provided. Let us test the angles which is 0, 90, 180, and 270. Test them provided with these values that we have here. All right. Let us try. So what do we want to try here? Sorry with that one. What do we want to try to test? We want to test that if I have sine 0 degrees, what do I have? Coming back to this without the use of a calculator, coming back to here, we know that in this point we have 0, and in this point is nothing but, if I were to plot the coordinates of this point, the coordinates of this point are just 1 maps 0. So in the respect of x and y, I can see that this point, my y value is 0, but my x value is 1 at this point, right? Where my theta is equals to 0. So at where my theta is equals to 0, I have this point in this quadrant. Tells me now that sine theta equals to 0 is nothing but it is equals to, provided to the ratio here. Firstly, let us remember the ratio. Or let me just write the ratio so that we can understand. It's just y over r is equals to 0 over 1 and is equals to 0. Okay, so we know that one. So now let's just say sine sine 90 degrees. Now let's go to sine 90 degrees. If we can come back here in sine 90 degrees, we know that sine is in this point, and this point, it is just nothing but it is a value of 0 maps 1, where my x here is 0 and my y here is equals to 1. So I'm interested in y, so it will be 1 over the constant radius, which is 1, and it will be 1. And let me have sine 180 degrees. Alright, so remember I'm having them as positive 180 degrees. Then I come back here. So when I come back here, what do I know? That here in this side I'm having my minus 1 maps 0, where this one is my y also, because I just need y. So the answer will be 0 equals to 1, and the answer is nothing but it is equals to 0. Let me just check. The final one is sine 270. So sine 270 is in this side. We can see, sorry with that one. Sine 70 is in this side. We know that this side is nothing but it is equals to, okay, let me just write it on this side. Okay, inside here it is equals to 0 maps minus 1, and this is 1 is my y that I'm looking for. So this one is nothing but it is minus 1 over 1. The radius is always positive, note that, and it is minus 1. So now, and finally, let me just have my sine 360 degrees. So sine 360 degrees is where also 0 was plotted. So they share the same point. This is a point that they share here. It is equals to 0 over 1. So it is equals to 0. You can check this one using your calculator. Pause and just plug these values using your calculator. You will see that your values will be as accurate as before. Okay? Good. Now the second step that we need to move. The second step, let me just clear something here. Let me clear this one. Let me clear all these ones. Let me clear everything here. All right. Let me clear this and that so that we can move forward and freely. Let me clear that and that. Okay. All right. So after we have done growing this one, picturing these values over here, picturing these values over here, now we want to grow the graph. But before we draw the graph, what do we need to know here? We need to ask ourselves, what if these values were negative? What if these what if all these angles are negative now? If I'm having I know that we can have negative 0, so it will be just 0. But what if I'm having 90 in negative, 180 in negative, 0 in negative, and whatsoever in negative? Remember that for this case, if I'm having sine with 0 plus or minus 0, I know that there is nothing like this one. I will always have 0 here. Okay, and here also, if I'm having sine, okay, negative 180 degrees, it is 0 regardless of whatsoever side here. And also here, sine negative 360 degrees, it will be nothing but it will be 0. So don't be just fooled by this one. Why to be 0? Because regardless, I will always have 0. Regardless, we will always have 0 here values. So we'll be not having any negative, or that will just have 0. It's the same thing. But the part that become a little bit complicated, not complicated per se, but the part that changes is this part. Let me just use the blue one. Is this part here. So if in this I come and I'm having my sine with minus 90 degrees, it changes everything. So you will see that coming back to the Cartesian plane, let us draw the reversal. We know that if we were to turn back and we want to go in this following the watch, the watch, which is a clockwise, I don't know what's so called, the anti-clockwise or a clockwise, but if you want to following the watch direction, we will get ourselves having minus 90 here degrees, minus 180. That's why I said we'll be having here minus 270. And coming back here, we'll be having minus 360. We'll come back to 360. If we are going anti-clockwise, if we are following the watch direction, I don't know what it's called, clockwise or anti-clockwise, you can correct me there. So now, because now I'm going, if sine is negative, is taking the position of 270. You can check here that the position of 270 is just minus 1. So if I come back here, I will say that I having minus 1 over 1, and the answer is minus 1. Also here, sine 270, negative 270, sorry, degrees is nothing but it's taking the side of 90 here, where there is a positive value of 1. So it's nothing but it is equals to 1 over 1, and it is equals to positive number 1. Okay, for that now we have these values. Let us try to plot the graph showing these values. All right, now let us plot our table. I just want us to use this table though, because some they understand this table. It's not wrong to understand this table, but you see, we'll draw this table without using a calculator. We'll just fill in the values and then we can draw our graph. Right, let us come here and plot this one and assume this is our is our input, so it's our x values, the angles. Let us plot them here, starting with the negative one. So plotting our values. Okay, let me just have the white one and we can have it. So we'll be having here, we'll be having minus 360 degrees, and we'll be having minus 270 degrees. Okay, it's 270 degrees, have a big 0. Okay, so I don't want to waste time here. Minus 180 degrees, and I don't know, it will fit here. Minus 90 degrees. Okay, 0 degrees, 90 degrees, 180 degrees, 270 degrees here, and lastly is 360 degrees. Okay, now let us put the values. Let us plug the values. We know that we said if it is 360 degrees, it's just 0, it's just 0, it's just 0, it's just 0, it's just 0. Then we say here it is positive 1. Positive is positive 1 here. We say here is negative 1. So in this side it will be negative 1, but it will be the positive 1 here. And this is our values. So after we have grown our values, we have just have our values. Let us just try to grow a Cartesian plane here. Okay, I draw angle. So let me just pause and draw the Cartesian plane. All right, we're back. Then I've managed to draw my Cartesian plane. Now let us plot the values into the Cartesian plane and plot the graph. So here we'll be having, let's just select the pen of specific colors here. Let me just, I thought I selected the right point, right? All right, so here we'll be having minus 360 degrees here. Here we'll be having minus 270 degrees. Okay, my spacing will be not perfect. Minus 180 degrees. Minus 90 degrees, 90 degrees, 180 degrees. My spacing, I've said that my spacing will be a little bit not perfect, but I'm trying. And 360 degrees. So now we have the values, and we have the values here is over 1 over 1. So now let us begin plotting the values here, right? So plotting, we said that if we have 360, we are here at 0, but we said that if we have negative 270, we have positive 1. So here we belong, over here. Here we belong here. We plot over here. So we come back at 180 is 0, but in 90 here we belong. Minus 90 is where we belong. So in 0 degrees we are at 0, and in 90 we come back here. 380 degrees we come back at 0. Then we go down here Then after that we go back at 0 because it's where the graph started, and it is called a period sometimes. Others will refer it as a period. And now let us plot our graph here. Let us plot our graph. So this is our graph. Okay, funds will go like this one. It'll go down here, it'll go down here, it'll go up, it will go up, reaching this side, also reaching this side, also reaching this side, and voila, our graph will end here. Then we name this graph that this graph is nothing but it is y is equals to sine x. So it is y is equals to sine sine x. So sometimes they'll say it is y is equals to f at x. So now we have drawn the graph. It's very simple and it's very straightforward. Now the next video we will be just looking to this graph and trying to apply some questions, some analysis of this graph. Thank you very much with your time.